Alright, so let's continue the topic differentiation. So differentiation is the process of finding the derivative. Finding the derivative. Okay, well, next let's learn some basic differentiation rules. First one is called find the derivative of function using the sum and difference rules. Find the derivative of sine cosine functions. First of all, let's take a look at constant rule. Constant basically is just C. Any constant, right? So derivative of any constant C, any number, any real number C becomes 0. Okay. So that's basically the constant rule. Let's take a look at the derivative of a constant function is 0. That is, if C is a real number, then the derivative of C is equal to 0. Let's take a look at this graph. So we have a constant function f of x equals C. The slope of horizontal line is always 0. That's why the derivative of constant function is 0. So as you can see, there's a relationship between the slope of the tangent line and the derivative. Slope and derivative, actually they are identical terms. So the derivative of a constant 7, any constant will become 0. So dy over dx equals 0. Derivative of 0 is 0 as well. Derivative of -3, 0. And the last one, y equals k times pi square. K is the constant. Pi square, pi is approximately equals 3.445. As infinitely many digits. But since it's real number, squared of that will become a constant. So derivative of constant is 0. Okay. And next thing is the power rule. So this is probably the most widely used. Differentiation technique. Before proving the power rule, it's important to review the procedure of expanding a binomial. So first one, let's say we have a parenthesis x plus delta x squared. Since it's a perfect square, so it will turn out to be x squared plus 2x times delta x plus delta x parenthesis square. Similarly, x plus delta x parenthesis to the third become x cubed plus 3x squared times delta x plus 3x times delta x squared plus delta x to the third. So the general binomial expansion for positive integer is x plus delta x parenthesis to the n becomes x to the nth, the first term. Second term, n times x to the n minus 1 times delta x, third term, and this is last term. Third term is n times n minus 1 times x to the n minus 2 over 2 times delta x squared plus infinitely many terms in between this, between the third term and last term. last times delta x to the nth. As you can see, right, starting from the third term until the last term, the exponents of delta x is definitely bigger than 2, greater or equal than 2. So delta x squared is the factor of these terms. I'll show you why this is important in x when we prove the power rule. So binomial expansion is used in proving a special case of the power rule. Okay, I'm going to see that in a second. So in the power rule, if n is a rational number, then the function f of x equals to x to the n is differentiable, and the derivative of function x to the n becomes n. The procedure is quite straightforward. Put exponents n in the front of the exponents and reduce the exponents by 1. And that's how we apply the power rule. For f to be differentiable at x equals 0, n must be a number such that x to the n minus 1 is defined on an interval containing 0. Basically, just make sure x to the n minus 1 is defined at x equals 0. That's what it means. And we're going to prove it really quick using the limit definition of the derivative. So I have a limit delta x approaches 0. So prime of x equals to limit delta x approaches 0 for f of x plus delta x minus f of x over delta of x. First of all, we're gonna see what that is. Since our f of x is x to the nth, so f of x plus delta x should be x plus delta x to the nth. So now we have x plus delta x to the nth minus f of x is x to the n over delta of x. Then if you expand this, becomes x to the n plus n times x a minus 1 times delta x. It's exactly the same as previous slide, which is this, right? This whole thing. Okay. The next term is plus n times n minus 1 times x to the n minus 2 divided by 2 times delta x to the second. I have several terms between, a lot of terms in between. Delta x to the nth minus x to the nth over delta of x. As you can see, this term will be cancelled. X to the n will be cancelled x to the n, right? So we're gonna divide into the, so we're gonna limit delta x approaches 0. So the first term becomes n times x a minus 1. Delta x get cancelled. Plus whatever remains over there will include delta x a minus 1. As you can see, starting from the second term, every one of these will contain a delta x. When we plug in delta x equals 0, do a direct substitution. So the result we end up with limit delta x approaches 0 n times x a minus 1. And with respect to delta x, this term actually is a constant. So the limit becomes x times n minus 1. N times x to the n minus 1. Okay. That's exactly the same as what we have over there. Okay, so that's a proof using the limit definition of the derivative to prove it. We use the power rule, the case for which n equals 1, meaning derivative of x is actually 1, right? Proof of this 1 we don't call that proof, maybe just a confirmation of this. So exponent is 1. So basically put an exponents in front, reduce exponents by 1. So 1 times x to the 0. X to the 0 is 1. 1 times 1 gives us 1. Okay. So this is a quick confirmation of what we just went over. The rule is consistent with the fact that slope of the line y equals x equals 1. Show that. So that's why slope of line equals 1. Derivative indicates derivative is equal to 1. Okay. Right, so let's use the power rule to find the derivative for all these three things. A f of x equals to x cubed. The prime of x, applying the power rule. So as I mentioned, put the exponents in front to reduce the exponent by 1. So we get 3 times x squared. 3x squared is the answer. Second one, B, we have g of x equals cubic root of x. So you also apply the power rule, you get to turn into exponents. So going from radicals to exponents, you put a base x, and then the power is 1 over the index 3. Now it becomes exponents. Next thing, you're just using the power rule. Put exponents in front, reduce the exponents by 1. So you get 1/3 times x to negative 2/3. So the next thing, you just make it a fraction, flip the denominator, so it becomes 1 over 3 times x to the 2/3. Okay, that matches what we have here. And the third one, we get a y equals to 1 over x squared. If you flip this to the top, it becomes x to negative 2. Now we can use that power rule. So y prime, put the exponents in front as coefficient and reduce the exponents by 1 and multiply them. Now we have a negative 2 times x to negative 3. Make it a fraction, flip the exponents to the denominator, it becomes negative 2 over x to the 3rd. Okay, so that's the solution behind this. Next thing, let's take a look at constant multiplier rule. So if this differentiable function and c is a real number, then c times f is also differentiable, and derivative of c times f of x becomes c times f prime of x. Okay, so we're gonna use the constant multiplier rule to figure out these answers. A, we get y equals to 2 over x. Same thing as 2 times x to negative 1. Okay, the next thing is to find the derivative. Y prime, we apply the power rule. 2 times negative 1 goes in front and reduce the power by 1. So end up with 2 times negative 2 times x to negative 2. Just like previous, flip the denominator, it becomes negative 2 over x squared. B, we have a f of t equals to 4t squared over 5. We could just easily separate them into 4 over 5 times t squared. So a prime of t. And this, pay attention to this. This is a derivative with respect to time t. with respect to t. So it's 4 over 5. We apply the power rule here to t 2 minus 1. This becomes 4 over 5 times 2 times t to the 1, which is a over 5t. Okay, let's be c. We have y equals to 2 times square root of x. And square root of x becomes x to the half. After that, you can apply the power rule. 2 times half goes in front, times x half minus 1. 2 times half becomes 1, 1 times x to the negative half. Make it a fraction, flip the denominator, it becomes 1 over x to the half. And x to the half is exactly square root of x, so it's 1 over square root of x. And second to last, d. Y equals to 1 over 2 times cubic root of x squared. And first of all, turn into exponents, so it becomes half times x to the negative 2/3. After that, you can apply the power rule, constant multiplier rule. That's what we call. So it's half times negative 2/3 times x to negative 2/3 minus 1. So half times negative 2/3 becomes negative 1/3. 2 got cancelled. Becomes negative 1/3 x to negative 5 over 3. Now I flip it to the denominator. Becomes negative 1/3 times x to the negative 5 over 3. And you flip the bottom, become positive, right? Okay. And the very last one, e. Y equals negative 3 over 2 x. So I prime, put a constant in front, derivative of 1x becomes 1. So it's negative 3 over 2 times 1 is negative 3 over 2. Okay, that will be exactly the answer shown above. So the constant multiple rule and the power rule could be combined into one rule. So derivative of a constant times the exponents eventually becomes c times n times x to the n minus 1. Okay. And the very last thing, let's take a look at sum and difference rule. The sum or difference of two differentiable functions f and g is itself a differentiable. Moreover, derivative of f plus g or f minus g is the sum or difference of derivative of f and g. So the sum rule, when we combine function f of x and g of x and take the derivative, you can just take the derivative of f of x, f prime of x, then adding derivative of g of x, which is g prime of x. Okay. Similarly for difference rules, when you take difference of two functions and take derivative, you can take derivative first and apply the difference. Okay, f of x equals x cubed minus 4x plus 5. So f prime of x, we just gotta separate into three different terms, right? Take the derivative for x cubed first, use the power rule. Derivative of x becomes 1, derivative of constant 5 becomes 0. So it becomes 3x squared minus 4 plus 0. So it's 3x squared minus 4. B. G of x equals negative x to the 4th over 2 plus 3x cubed minus 2x. G prime of x, we separate into 3 different functions and find the derivative and combine and find the difference. Negative half. Put the exponents 4 in front. Reduce exponents by 1. 1 minus 1. Plus 3 times 3 x 3 minus 1. 2 times derivative of x becomes 1. So negative half times 4 becomes 2x to the third plus 9x squared minus 2. And the very last thing, let's take a look at the derivatives of sine and cosine functions. So derivative of sine becomes cosine. You can use the limit definition of derivatives to prove this. So derivative of sine x become cosine x, derivative of cosine x will become negative sine x. Okay, very straightforward. Just a derivative of either sine or cosine to reverse to the opposite one. Okay. So derivative of y equals to 2 times sine x. Constant remains, and derivative of sine of x becomes cosine of x. Second one is y equals to sine x over 2, which is half of sine x. So derivative of that, keep the half. The derivative of sine x becomes cosine x. And it becomes half of cosine x equals to cosine x over 2. And the very last one, see y equals to x plus cosine x. Derivative of x becomes 1. Derivative of cosine x becomes negative sine x. Okay.